over Quad State, I actually had, about 20 people asking me about this burner idea that I've got, and if I was going to put any more information out. Well, I am. I'm going to do that now. We're going to talk about this, and I'm going to put together some part sources in case anyone wants to try to get on here and basically recreate this burner. Just a little warning note here. You're playing with air, fuel, fire. It's dangerous. Don't burn your house down. If you do burn your house down, please don't blame me for it. You are warned. If you have the technical skills, this is an easy thing to recreate, but I'm telling you, this thing is hot enough to melt steel. Inside this piece that you see here is this. Alright, so what is that? Alright, I think a lot of you probably seen my other videos and know exactly what this is. This is a siphon oil burning nozzle. It is designed to use kerosene or coal oil and is usually used in, say, a boiler or a water heater. I think they also use these in certain jet burners, but I'm not certain of that. This one in particular is used to heat water. Compressed air comes in this side here and goes around here and basically as it goes through here it creates a vacuum and it pulls your fuel through this line and then atomizes it and comes out of this nozzle here. This nozzles can be replaced with larger holes. This is a 2mm. This is quite a large hole. This is a bigger nozzle than my test nozzle that you could see in some of my other videos. Some improvements to this. Alright, let's get this up here. It doesn't want to roll. Alright, starting with this device here. This is our compressed air line coming in from an air compressor. This is a little needle valve, and it really doesn't do a really good job of controlling the air pressure in there. It really doesn't. You can dial it down a little bit, but it does a really crappy job. I was at Walmart today, and I saw they had these little bitty small air regulators. I think Campbell Hallsville or whatever. They would be a much better choice for this, so I'm thinking about building and putting one of those in here next time. Each burner will have its own fuel regulator, and I would also like to put what's called a flow meter in. They can be picked up at welding stores. We don't want to put this all the way up here. The reason for that is this is brass. So brass melts, so I'm trying to keep it kind of up a little bit in the airflow to protect it. The air coming in, the compressed air, and the fuel is helping keep this nozzle cool. One of the bad problems we have with this is the pattern of spray that comes out of this is hitting the sides of the pipe and creating droplets that run down into the forge. That is not a problem once the forge is hot. It doesn't care. It's going to burn it. However, I think we could get a more efficient burn if we could stop that from happening. The way to do that is use a larger pipe, much larger diameter pipe. We can look at the fan pattern here and make this pipe bigger. The other issue, this pipe doesn't need to be this long. I mean, I've already kind of figured out that, we could probably cut this pipe down to, 8 inches long here. Make this a 3 or 4 inch diameter pipe. Have our air inlet right here. This still needs to be intersecting this, say at 30, 40 degrees. We want the air to already start going that direction. Another thing we need to add is inside here a way to create a spiral flow. I thought maybe the easiest way to do that would be put a ribbon on the inside of this. Just one ribbon, kind of like you'd have in a gun. As the air comes in, it starts to spiral as it goes in. Creates a better mix. The air inlet tube doesn't have to be this long either. Okay, let's look at the design now. Alright, forgive my terrible drawing here, but the change, as you can see, as we just discussed, would be using a larger burn pipe here to where we can keep the atomized oil from hitting the sides here and condensing. Okay, you can see in comparison. Also, the length can be a lot smaller than that. I'm going to make one of these next time. The other thing would be this internal fin, which I can't really draw this real well. But let's just say, look at the rifling in a gun. Only we're going to have one rifling piece inside here, maybe a half-inch ribbon of steel. You know, that will cause it to turn. Up here, our inlet, this would be much shorter as well. You know, ideally you only need like 5 inches incoming. This burner we adjust where it doesn't hit this pipe anymore. And then, of course, also consider the regulation and the flow meter on the outside here. This nozzle, you can actually purchase that nozzle on Amazon.com. There's one made by Delavan. This nozzle here, I ordered it from eBay at a link that I'll pull up, or something similar. I believe I paid $5 for this assembly, but it took me 3 to 4 weeks to receive it. So next time I place an order, I'm going to order 10 of them, I think. These are compression fittings. I went down and bought them at my local hardware store. I'm not a plumber or whatever, so I really don't know what to tell you here. I think this is a 1/4 inch compression fitting with a little, ferrule in there. This is like a 1/2 inch to 1/4 inch compression fitting with a little layer in there. This is steel brake line, and I bought this from Napa Auto Parts, but you can get it, anywhere. I recommend getting the straight pieces, because you can get rolls of this stuff, but these things are almost perfectly straight from Napa this way, and they're stout, so I'm not going to add anything to support that. So I highly recommend just getting the steel uncoated brake line, a quality type. Don't get it in a row, because you have to straighten it. The pipe, choose your weapon there, guys. This pipe, I bought it at Ace Hardware. It was expensive for me to buy it at Ace Hardware. I can't help but feel that if you have the ability to work with it, I think you'd be much better off using exhaust pipe, and just, it's thinner wall. You don't need this thick wall stuff. It's not necessary. It doesn't get hot enough up here to melt. If your forge is insulated, this should not get hot enough to melt. So this thick pipe is way overkill, guys. Also, I'm not a welder. This is brass. It's horrible, okay? Don't make fun of me, but, I tried. That's all I had. So, if you could TIG weld that, oh, that'd be awesome. You don't even have to have a screw-on fitting. I like the screw-on fittings just because I wanted access to it. I take it in and out, whatever. The compressor fittings. I highly recommend using these barb fittings with clear line for the fuel so you can see what's going on. It helps you diagnose some stuff. On the compressor line, use your standard compressor fitting. All right, let's talk about fuel filters. You have to have a fuel filter for this because dirty oil is what? Dirty. So the test that I did, if you look back at my test videos, and I recommend that you do that, please, I used a standard, I guess, heavy-duty lawnmower fuel filter. For kerosene, it worked fine. For the bacon grease that I ran through it, it was fine. But the motor oil, it didn't do so well because the particulates that were in the oil plugged up that little filter really quick. The oil I was using was very dirty. It has been sitting outside for a long time. It has absorbed some water and some moisture, and it has oxidized, I guess. Excuse me. So what I recommend you do is make your own oil filter. Environmentalists are going to hate me for this. Now, when I say make your own fuel filter, what I mean is go out and get yourself a piece of, 3-inch PVC pipe or 2-inch PVC pipe. Yeah, get you a cap on one side, and like this. Those rounded ends would be the best, of course. On the other side, I haven't quite figured this out yet, but I think we can get these screw-on caps up here. This thing needs to be airtight because we're going to be pulling a vacuum through here and oil is going to be pulled through this. But what we would want to do is fill this up with some sort of a filter material. The filter material could be or cotton. Fill the cotton up in this thing. We're going to make a big column, and you fill all this up with your filter medium. It should last a very long time. You should not have to change this very often at all. And you have your hose here. This is your output that goes into your forge. You have your input up here, which goes to your tank. And forgive the drawings. Going this way. Oil's going this way. Oil's going that way. Alright, so this is a big column. There's a lot of surface area here that will hopefully keep you from getting clogged up. And like I said, this will last a long time, people. One issue you may have with this is I don't know if water will have a tendency to collect in here, but the way it is, it's in and out. So if you're getting water, it's going to get pushed into your forge and burn up. But anyway, that's my ugly burner in a nutshell. I'd like to see this thing get developed. I'm going to develop this either way. Maybe by Quad State next year, I'm hoping to have a few of these things I could take with me. Maybe I'll sell a couple of them. Who knows? I don't know. But if you guys want to copy this, it's not a patent on it. This is not my burner idea at all. A lot of people are using variants of this burner right now to melt steel in foundries. Used oil foundries, which I'm interested in doing that as well. But it goes hand in hand with forging. It gives us another fuel source. It gives us the ability to heat metal rapidly. And one other thing I should let you know about this. This forge, if you preheat this forge using propane, you get it hot. This oil, switching it over to oil, you'll get no smoke. It's just really nice. You can actually, what I was planning on doing was the air compressor line in on here. I'm going to put a valve system, just 2 valves. So let's talk about that. So we have a valve, if I'm drawing this right. Two valves going into one here. And this goes to our burner. Yeah, flames. Okay. This is going to propane, LP. This is going to, oil, to air. So what you can do, and we can turn the oil flow off, turn on the propane. Propane's coming out of this orifice. It will flame, heat things up. As this thing gets hot, you turn on your oil, turn off the LP, turn on the air. There will be enough residual heat in there where you don't have to worry about it going out. Turn on the air, turn off the LP, and you'll be burning on used oil, and you won't have any smoke. I'm trying to source a valve that will do this in one option, where you can't turn them both on simultaneously. If you all have any ideas, let me know. I thought there would be something in the RV world that had like a manual switch over between tanks or something. I put you some sources. That's about as far as I can take it at this time. I'm working on building a forge, and I just have to get my infrastructure in place before I get that finalized. Once I do, I will be using this burner, and I'll post a lot of videos on it because I'm going to be using it exclusively. Anyway, peace.